Shake Table Lab by Eliza Levy and Jamie Brennan. The building sketch helped my partner and I visualize what our building was going to look like. It shows that the first and the second story had to be at least 18 centimeters. We also labeled each wall. This helped us see what we needed to do to make our building. First, my partner and I started working on the 3D version of our previous sketch. First, we tried to make a square for the bottom out of our straws. We attached it to the cardboard base and then started to build up the walls. Mr. C drilled holes in the cardboard so we could put a straw through the hole and make it a more stable wall. After making sure that our walls went up 36 centimeters, we started working on the first story. We put our first straw going horizontally across, connecting two straws together at 18 centimeters. Once we placed that one, we were able to continue placing straws in a square-shaped formation. When we placed both stories onto the building, we went back to our first story and added some crosshatches. They went from one corner of the building to the other. We did this to add more support. We did this on both stories, and after finishing, we added in some blue paper and placed it on top of each level. Next, we started working on our roof. Our roof is a design called a staircase. We made this by attaching and cutting little pieces of straws together, and after finishing one level of the roof, you would cut another straw and place it on top, until you have a design that looks like a staircase on top of your building. Finally, we have our finished product. As you can see, we have made several changes from our original building sketch. The second story ended up being 20 centimeters and not 18. We also ended up adding a roof. The static testing is where we put bean bags on the stories to see if they can withstand any weight. My partner and I put 2 bags on the first story and 2 on the second story. Putting the bags on the building also helped us show where the weakest and the strongest parts of the building were. Some of the strongest parts on our building are the crosshatches, the straws in the middle of the building, and some straws that were bundled into threes. The crosshatches help support the stories and also shape the building. Our building was tilted, so we added these to make it straighter. The straws in the middle also help support the level above it, and the straws that were bundled in threes add more support to the walls. Overall, I think the strongest part in our building is the bottom story. We have put some straws in the center, and we also added some crosshatches. The crosshatches help support the walls. They prevent them from collapsing. Also, for the walls, we have 3 straws bundled together. This adds a little more strength to the walls and to the higher levels. Overall, I think the strongest part in our building is the bottom story. We have put some straws in the center, and we also added some crosshatches. The crosshatches help support the walls. They prevent them from collapsing. Also, for the walls, we have 3 straws bundled together. This adds a little more strength to the walls and to the higher levels. I believe that the weakest part in our building is the roof. The roof is probably the weakest because it doesn't have a ton of support. There's not a lot of support holding up the roof and the donut. To build our building, we had to use a lot of tape. The tape helped stick 2 straws together so we could make our roof and our other stories or walls. Unlike the other resources, we could use as much tape as we wanted or needed. As we started making our building, Mr. C would give us more straws because of the new building codes. We were given more straws to make the roof, so you could have made any design you wanted. We were also given some paper to make the stories and the roof, as well as our design on top of our roof. Our building successfully held 8 sandbags.
Oh my god, no, this is for 9. Oh my god, this barely lasts. Keep it up. Wait, but I can't do it, please. Oh!
Our tower collapsed almost seconds after we put the 10th sandbag on.
Start off with 2. You can't just go like that. You have to start off just like that. Oh my god! Liza, last.
Finally, we have the XYZ graph. This graph helps show us how big the earthquake was that hit our building. The blue lines measure up and down movement and have a scale that goes from 1 to 4. The orange lines measure the back and forth movement. Its scale goes from 4 to 2. The last scale is green and measures the side-to-side motion. It has a scale that goes from 12 to 12.
This is Olivia reporting live. Jamie in my building held 8 whole sandbags. It failed on the bottom crosshatches on the first story. If I can change anything about the building, I would make the walls closer together so all the straws can support each other. I learned that when you're making an earthquake-proof building, you have to make sure that it's completely supported throughout the building, and the bottom story has to be the strongest because that's what carries all the weight. I enjoyed watching the building fail and doing it with all the classmates. It was so much fun. Thank you and good night. Hello, this is Jamie Brennan reporting live. Me and Eliza's building successfully held 8 whole sandbags. It failed in the bottom left crosshatches because the straw above it was way too weak. I would have added a couple more bundles to it to make it more supportive. When I would have changed our building because I would have made it a little bit tighter because we had a ton of space that didn't have any support. There were like no straws. It was really, really weak. I really enjoyed this lab because I got to experience what it was like to build an earthquake-proof building out of straws, paper, and tape, and it was really fun to watch our building collapse. I learned that when you're making an earthquake-proof building, you have to make sure you have a ton of support, otherwise it's going to crash almost immediately. Thank you!